Hello friends, in this video I am talking about building management system BMS system. So let's get started and see. First the basic explanation explained. Okay, so let's get started. What is BMS? Second is what does it do? Third is benefits and fourth is operational considerations. So let's get started. What is BMS? Industry in jargon, terminology and acronyms. What is building management and control system? BMS supply and integrators, typically system components and typical user interface options. Okay, so let's get started. Building management system BMS, also known as the building automation system BAS. Okay, building management and control system BMCS, direct digital control, any DDC and building controls. Okay, other term associated with control system includes like SCADA supervisor control and data acquisition. Second is PLC, programmable logic controllers. Third is EMS, like energy management system. Fourth is data gathering panels, DGP. Okay. Next is Modbus, Loadworks and Basins, all refers to communications protocols. Next is front end, legal terms used to refer to the BMS operator workstation. Okay, most common current industry terms like building management system BMS and building management and control system BMCS. Okay, what is building management system? So let's get started. BMS system are the intelligent microprocessor based control networks installed to monitor and control buildings technical system and services such as air conditioning, ventilation, lighting and hydraulics. Okay, second is more specifically they link the functionality of individual pieces of building equipment so that they operate as one complete integrated system. Now, installation in very major building or facility with the availability of direct integration into the all building service such as security, access control, CCTV, fire, lifts and other life and safety systems. Okay. Current generation BMS systems are now based on open communication protocols and are web enabled, allowing integration of system from multiple system vendors and access from anywhere in the world. Okay, how does integration microprocessor control means? Okay, this is networks, outputs, CPU, mouse, you know already. Okay, this is the how does integrated microprocessor controls mean. This is called DDC panels. Okay, all connected to DDC panels like chiller, valves, control valves, temperature meter, etc. Okay, BMS supply and integrations. Okay, let's get started. Produced as the complete system that include the engineering, supply, installation, programming and commissioning. Specialist integrators that are the either direct associated with the manufacturer or are the approved reseller. All integrators should have full factory technical support. Need to work closely with the mechanical service and mechanical, electrical and other contractors. For the new construction, BMS is usually including within the mechanical service package. Okay. Tier 1 company only refers the direct factory association and not to the quality of products or service. Okay. Range to suitable application work. What is this is operator workstation and high points counts, range to suit applications, limited feature building built-in display and a small point controllers etc. Okay, typically system components field device like damper actuator, valve actuator, variable speed drive VSD, air flow pressure, pump fan motor, water flow pressure and voltage currents, temperature relative humidity, chiller boilers, cooling tower, etc. Okay, all connect to DDC panel like BMS panel. Okay, typical system components and networks. First, web browser connect to server, workstation. Okay, after that, workstation connect to, this is the integration in. Okay, typical user interface options. So let's see. Can be a basic LCD display thought to full graphic operator workstation. Second is the graphic interface must be intuitive to use and not require an the engineering degree to encrypt. Third is they must provide sufficient level of detail to enable the operator to determine what is happening and what is going to happen next. Okay. Next is graphic need to provide access to parameters for turning and seasonal information needs to build into the system. Okay. BMS simple user interface built-in display. User defined menus built into the BMS control or a remote device. Password protected monitor and the control field points, operating set points, time schedules, alarm management, event trend data. Okay. BMS simple user interface web service. Web service built into a BMS network controller. User defined means menus and graphic page. Password protected multi-access levels. Monitor and control fields points, operating set points, time schedules and alarm management, even trend data. Okay. BMS workstation HU graphics display. This is the display of HU graphics, how HU does works. Okay, BMS workstation, this is the chiller graphics. All need in all information about chiller like set point, inner temperature, all the information in this graphics you can see. Okay, how does a BMS do? So let's get started. The role of the BMS in day-to-day building operation. Second, building control applications. Third, measuring and monitoring building performance. Fourth, interaction with other building systems. Okay. Next is the day-to-day role of the BMS. The most common primary function of the BMS is the control of the building heating, ventilation, and the air conditioning system (HVAC), including in HVAC air handling units, chiller water plant, cooling tower, tenant condenser water, heating water plant, exhaust system, zone control, computer room, AC. Okay. The day role of the BMS. So let's see. Control control of building system and services. Second is graphic user interface GUI. Third is real-time monitoring of building operation and performance. Fourth is trending and the logging of building operation and performance. Next is time scheduling of building system. Next is fault management and alarming. Next is control application programming. Okay. User event management, energy management and reporting. Okay. So let's get started and say the building control appliances. So let's see. Building control applications including four following. First, zone temperature monitoring and control. Second, zone variable air volume, behavior control to zones. Next is zone CO2 monitoring and control air quality. Next, air handling unit supply air temperature control. Next, air handling unit supply airflow pressure control. Next, main plant chiller and boiler sequencing. Next, toilet, car parking, kitchen and general exhaust fan control. After hours building control. Okay. Measuring the monitoring building performance. So let's see. Operator interface including the graphics user interface GUI for the monitoring and adjustment. Second is trend data is important when the determining the stability of control algorithm and when the tuning the system. Reports and pivotal when the demonstrating building performance against the sustainability targets such as the NABERS. Okay. equipment alarm and fault notification, reduce downtime and consequential impact. Okay, this is the interaction with other building systems. Okay, this is DDC networks, lightning network, meter network, emergency lightning network, CCTV network, security network, other network and fire network, all in DDC. Okay, benefits of having a BMS. So let's see the advantage of BMS: variable various standalone control, improve tenant comfort condition, energy management and reduce operational cost, management of building ratings such as the neighbors. Okay, advantage of BMS is stand-alone control. So let's see. Reduce the installation cost, flexibility and edge to change, customize control strategies, scalability, operation interaction, feedback and control, interaction with other building services. Okay, improvement tent comfort conditions, real-time monitoring of the tent conditions, great load-based control strategy, tent data of performance, improve fault finding, air quality management like CO2, after hour operation request, tenant billings, alarm notification of fault, reduced downtime, automated change over the hour of failure equipments. Okay, energy management and reduce of operational cost, optional start and stop plant, building warm up and cool down cycle, night purgage, automatic seasonal plant sequence selection, seasonal temperature setting adjustment, load based control strategy and economy cycle control including CO2. Okay, equipment runtime monitoring and duty cycling, occupancy control and control setback. Okay, next is management of buildings rating, NABERS, can be integrated with energy management system, EMS, real time monitoring of energy performance, proactive adjustment, not retrospective catch up, measurement against load profile targets, separation of tenant and base building loads, historical trend data for NABERS management, energy demand and consumption dashboards. Okay, all you need is BMS, management of building rating, NABS. Okay, next is operation considerations, turning and optimization, importance of system documentation, system maintenance, what, how, often and when, life cycle expectation and consideration. Okay, next is control loop turning, BMS turning and operation and optimization are not the same thing. Second, BMS tuning or control loop tuning ensures that the equipment operates in a stable, predictable, and repeatable manner. Okay. Next, optimization focus on the operating the equipment in the most energy efficient manner without the impact of the control variables. Okay, the first stage of optimization including BMS loop turning. Okay, like chiller running, supply air temperature 40 degrees Celsius, 14 degrees Celsius, static pressure 350 PA, and VSD running at 95%, VAB damper is 15% open. Okay, next, chiller stops, supply air temperature 18 degree, static pressure 200 PA, and VSD running 75%, VAB damper 85%. Okay, this is comfort zone and this is also comfort zone. Okay, important of system documentation, first is function description, FD, detail of configuration of the BMS, overview of the building service, describe in detail each of the BMS control strategy and sequence of operation. Document integrations between the each parts of the system. Point schedule. Detail all connected device and their point type. Critical for planning and system engineering. Next, control system drawing should include a network architecture drawing. Detail the physics wiring connection to controls. Useful for the fault finding as the establishing a spare capacity. Important system documentation. DI digital input, DO digital output, AI analog output, AO analog output, AI analog input, AO analog output, ALI high level interface. Okay. System maintenance. The BMS belong to the building owner who should act its administrator managing BMS access rights. Second, the BMS should be maintained with the appropriate level of servicing. As with any software driving system, data and files should be backed up on a regular basis. Next is critical components should be identified and checked at regular intervals. Next, BMS functions such as a train data reports and alarm can be used to perform maintenance by exception. Okay, maintenance should be approached as the performance of control system, not individual components. Example: HU and chiller plants. While the BMS equipment's vendor should be utilized to maintain the critical components, other suitably qualified technicians can be utilized for the field equipments. Okay, this is the BMS life cycle consideration. Con- Consideration. Check equipment production cycle status. Select hardware with proven record. Avoid beta. Check for level of software and hardware support. Check forward compatibility policy. Equipment life cycle. BMS field controls 15 to 20 years. Field device 15 to 20 years. BMS computer hardware 3 to 5 years. BMS software major release 3 to 5 years. Okay. Next is BMS, the basic explained recap. BMS systems are intelligent microprocessor based control networks installed to monitor and control building technical systems and services such as the air conditioning, ventilation, lighting and hydraulics. Okay. Scalable from Scalable from just one device to thousands of devices. Link and functionality of individual pieces of buildings equipment so that they operate as one complete integrated system. Next is provide the building owners and operators with the tools and manage the performance and energy efficient of their buildings. Okay. Next is BMS can be integrated into the all other building service such as the security, access control, CCTV, fire, lift and other life of safety system. Okay. Thanks for watching this video. Thank you. Are you like this BMS video? Please like this, and do you want to download this PDF? Please go to my website link in description. You can download this PDFs. Thanks for watching this video. Thank you.